from catastrophic failure to flawless perfection. How? Everything you know about programming robots is obsolete. In the next few minutes, we're going to break down the core machine learning pillars that transform a pile of metal into a truly autonomous system. And yeah, this is the tech powering a $100 billion market. Okay, let's dive right in. We are witnessing a fundamental, and I mean fundamental, shift in how we build intelligent machines.
See, it's no longer about painstakingly writing thousands of lines of rigid code for every single possible action. Now, it's all about creating systems that can actually learn and adapt on their own, from experience. The old way, a robot was only as smart as its last line of code. The new way, it gets smarter with every single thing it does. So the big question is, how do they actually learn?
Well, they learned a few key ways. You've got supervised learning, where we basically give them a cheat sheet, data that's all nicely labeled by humans. Then there's unsupervised learning, where we just throw a mountain of data at them and say, figure it out. But, when it comes to actual movement and making decisions in the real world, one of these methods is an absolute game changer.
And that method is called reinforcement learning, or RL for short. This is the key, the absolute key, to teaching robots complex physical tasks. Instead of giving it a super detailed instruction manual, you just give it a goal, the what, and you let it figure out the how all by itself, through pure trial and error. It's a lot like learning to ride a bike by, falling off a few times. And the process is so elegant, really. The robot tries an action. It gets a reward if it's on the right track, or a penalty if it messes up, and then it learns, it adjusts its strategy. You repeat that loop millions, even billions of times in a simulation, and eventually you get mastery. But of course, for this learning brain to work, it needs senses. It needs to understand the world around it.
And modern robots are packed with them. They've got cameras for computer vision, which are basically their eyes. They use LiDAR and radar to see the world in 3D, kind of like a bat's echolocation. And get this, some even have tactile sensors, so they can literally feel objects to understand pressure and texture.
But here's the really brilliant part. It's not enough to just have all these different senses. The magic happens with something called sensor fusion. This is where the robot takes all that different data, the vision, the 3D map, the sense of touch, and combines it all into a single, unified picture of reality. That's how a robot can truly perceive its environment with total confidence.
So perception is one thing, but what about actually doing something? This brings us to a massive challenge in robotics. I mean, if you've only ever trained a robot on perfect little cubes, what on earth does it do when it sees a weirdly shaped coffee mug for the first time?
Well, the answer is grasp prediction. And this is so cool. Instead of programming the robot to pick up a specific object, it learns the concept of grasping. Its machine learning brain analyzes the object's shape from all that sensor data and, on the fly, calculates the perfect grip. It can adapt to pretty much anything you throw at it. And this ability to generalize is where things get truly revolutionary.
Because the crucial point here is, we are moving way beyond just teaching a robot simple little actions. We're getting to the point where we can give them complex, multi-step commands, just using plain English. We're finally bridging that gap between human language and robotic action.
And this is all made possible by the newest frontier, vision language action models. Seriously, just think of them as the master brain connecting everything we've just talked about. They see the world with computer vision, they understand your command through language, and then they generate the exact sequence of actions to get the job done. They are the ultimate answer to our opening question.
And let me be clear, this technological leap is not just some cool experiment. It's the engine driving a massive $100 billion global industry. The ability for a robot to understand a simple voice command and perform a general task without any custom programming is unlocking just immense value in manufacturing, logistics, healthcare, you name it.
So what's the one thing you should take away from all this? The shift from rigid programming to this new world of dynamic, data-driven learning has created an entirely new foundation for automation. This is not some prediction about the future. This is the new architecture of automation, and it is happening right now. It fundamentally changes what is possible for machines, which really just leaves one big question, doesn't it? What tasks will we automate next?